Before explaining operation details on the tidal power station, can you explain me how the tides work and how is it possible so much water can be moved naturally?
Of course I can. The best way to help you understand the phenomenon of tides is to take a bird's eye view. As you can see, in the universe, there is a law, and it is called the universal law, discovered by Mr. Newton.
The one who hates apples?
Almost, but never mind. So this law explains the phenomenon of gravitational pulls. All the bodies attract themselves according to their mass and the distance between them. Thus, the Earth attracts the Moon and the Moon attracts the Earth.
Ah, I think I understand what you mean. Sea's water is also attracted by the Moon and move toward it.
Exactly, that is why seas and oceans are curved to the rhythm of the Moon revolutions.
But something's wrong. I know there are 2 tides per day, and the Moon revolves the Earth in 1 day. Yet according to your model, I would say just 1 tide per day. Why?
Nice question. I hope you ask me. In fact, gravitational forces between the Earth and the Moon is more complicated than I explained. Watch the following diagram together. Not only the water close to the Moon is attracted, but also the ground and the water in the other side. And as we know, according to the gravitational law, the farthest the object, the lower the gravitational pull.
So if I get it right, the resulting distortion shows that a tide appears opposite the Moon, which explains the mysterious phenomenon of the double tide. Therefore, we can have a tide every 12 hours and 25 minutes.
Exactly, and this phenomenon is amplified by the Sun when there is a line of syzygies, which means an alignment of 3 celestial bodies, and this results in large tides. In the other end, when the celestial bodies are in quadrature, the Sun's force opposites the Moon's one, resulting in small tides.
Okay, I understand. Thanks to mysterious astral movements, seas and oceans move on shaped tides on the surface of the Earth. Humans just have to harness this power to create electricity.
Thank you guys. Now we will explain how to convert mechanical energy into electrical energy. Indeed, the goal is to deliver alternative current to the grid. So, we have to use synchronous machine, an alternator. A synchronous machine uses magnetic interaction to do this conversion. The machine is composed of 2 main parts. The first one is the stator. It is the part which receives the magnetic energy and converts it to electrical energy thanks to these 2 coils. The rotor is the moving part of the motor. It is made with permanent magnet or electromagnet. A magnet generates a field, here represented with a copper wire. When it turns, due to water pressure, it creates a rotating field. This magnet energy is received by the stator coils and an alternative current is generated. The challenge is to create a precise 50 Hz alternative current with no parasites. That's why we have to adapt the number of poles to get the perfect frequency. When you increase the number of poles, you decrease the frequency of the signal for the same rotation speed. For instance, with 1 pair of poles, we need 1 rotation for 1 period. With 2 pairs of poles, we need an half rotation to generate 1 electrical period. In reality, an alternator looks like this, a car alternator. The number of poles depends on the application.
This one is fitted with 1, 2, 3, 4, 5, 6, 7, 8 pairs of poles
which are not permanent magnets but electromagnets. By contrast, the Rance tidal power station has alternators composed of 16 pairs of poles. It is due to the low main water speed.
But how can we use this alternator in tidal power station?
With the tide strength and the possibility to convert electrical energy with alternators, we can produce energy using a tidal power station. For example, there is the Rance Tidal Power Station in France, the first tidal power station in the world.
A tidal power station operates in the following way. When there is a rising tide, the water goes through a valve. When this valve is open, the water returning to the sea turns the pole of a turbine. This produces an electrical energy using an alternator.
We made a model to represent its operation. Tidal power stations have, like every energy source, advantages and disadvantages. In first hand, this energy is renewable and variable, but predictable years in advance. The cost of an exploitation is weak, and the durability of the station is important. But there is a risk of sediment in the basin as well as a silting which necessitates a regular expensive maintenance. And they also have an impact in the migration of fish as well as a modification of the wildlife.
The potential of tidal energy in the world is hard to estimate. It could be between 500 and 1000 terawatt-hours per year. In France, the average annual production of a Rance power station is 1 terawatt-hour, less than 1% of electrical energy from hydraulic origin.
In conclusion, the energy of tidal station is renewable and can be a promise of green future.